So in the last video we were talking about how in a lot of areas of the United States we're susceptible to strong ground accelerations from earthquakes. And in this video I want to talk about elements of what we call our seismic load resisting system. So if we're in an area where we have earthquakes, we need to design our buildings so they can handle it. Now, to introduce the concept of seismic load resisting systems, I want to start out by reviewing some principles of gravity load resisting systems, since that's something that people are probably a lot more familiar with. So let's talk about some of the elements of a gravity load resisting system. Gravity load resisting system. Okay, and the way to identify those elements is let's just draw a gravity load coming down on our frame somewhere. How about right here? And let's think about what parts of the structure get touched as that gravity load makes its way down to the foundation. In this system right here, it's just like a simple one-story building. We're going to assume that all the beams and columns are just pin connected to each other, and that this is some sort of roof deck or something. So let's consider how this point load gets transferred to the ground. Well, the roof deck, it has its stiffness in a direction perpendicular to the direction of the floor beams. You know, if the deck could span this far, then we wouldn't even need these floor beams. So the deck, we can think of it as spanning between these beams. So the load will get transferred through the roof deck out there, okay? And then from here, it'll come down that beam and then down the column. Here it will come down this beam and down the column. Okay, we've got a little bit different path here. Here we're going to come out to the beam, or maybe we can call this like a girder since it's supporting beams. And then from here, part of it will come over to this column and down, and part of it will come to this column and down. Okay, and similarly, we've got some that's going to come down here, and this guy's going to come to this column and down, and this column and down. So that's those are the paths that the load is going to follow to get down to the foundation. So let's make a quick list here, or what are the elements along that path. So we start off with the roof, or in some cases we might have a floor. We could have done an example where we had a floor instead. We've got beams, roof beams or floor beams. Okay, on this path we have what I'm calling girders, okay, or maybe just another level of beams, you can think of it as that. And then finally we've got our columns. So these are the basic elements of the gravity load resisting system: roof, beams, girders, and columns. Okay, now let's think about our lateral force resisting system. Okay, so let's now we're talking about our actually, let me use consistent wording. We're calling this our seismic load resisting system, not our lateral force. Okay, so our seismic load resisting system. Okay, and to look at that, let's kind of do the same thing as what we did above. Let's put on a load of some sort, but we'll make this some sort of lateral force that's pulling on our roof in this direction. And during an earthquake, we're going to have inertial forces up here in the roof. They're going to be acting in this direction, and they're associated with the mass. Well, how is this force going to get down to the foundation? Well, let me draw the paths and then kind of explain why it does what it does. Okay, what happens here is the roof, it's going to carry the force out to these two lines on the perimeter, this line and this line. And the reason the load wants to go out there is because those are the lines that have some sort of element that has lateral stiffness. Okay, and then from these lines maybe we go through the beam, down the brace into the foundation right here, and over here through the beam, down the brace, and into the foundation right here. Okay, now this is a little bit different than what we had above, because you can see that the load, it's staying in the floor, the roof, longer. Up above, you know, we just stayed at the from the point load, it just stayed in the roof until it hit a floor beam. Okay, but in this case, it's going to stay in the roof all the way till we hit some sort of line that can take it down to the ground. Okay, and so the elements in this system, if we're making a list of the lateral force resisting elements, okay, so the first element we're going to say is the roof, okay, or the floor if we were thinking of that example. And when in this function the roof is acting as a diaphragm. And so as a diaphragm, it carries the loads out here. Okay, the second element in this picture as I have it drawn is like a beam. Okay, but this beam, it's acting in a different way than beams usually act. Usually beams are carrying moments and shear. In this case, the beam is going to be transferring the load through axial stresses and resultant. Okay, so through axial force, and so we're going to call that beam a collector. Okay, so we've got these guys are acting as collectors. Okay, and then the last element of our system is, I'm going to give a general name for this whole thing. Okay, we're going to call it our lateral force resisting frame. Okay, and here I'm showing it as a brace frame. There's a brace there, but there are lots of different types of things that you could put here in this bay that could function as a lateral force resisting frame. So to summarize, for the seismic load resisting system in a building, we've got three important elements. Okay, we've got roof diaphragm, we've got beams that act as collectors, and then we have special lateral force resisting frames throughout the building. And seismic design is just going through and perform the analysis and design for each of these various elements in the system.